Hello everyone, welcome to my chemistry channel B.L.D, short and sweet in chemistry. Also I want to welcome the topic Lewis and resonance structure with formal charge, class 11th and 12th, and now especially part 6 in nitrogen dioxide. What is the formula of nitrogen dioxide? NO2. And here nitrogen dioxide NO2, first of all you will see what is the total valence electron of nitrogen dioxide. Nitrogen dioxide formula NO2, that means nitrogen and 2 oxygen. And nitrogen, what is the valence electron of nitrogen? That is 5. And valence electron of oxygen 6. Here the oxygen that having 6 and 2 oxygen, 6 into 2, that means here 5 plus 6 into 2, that becomes to 17. Here total number of valency electron of NO2 is 17. Now you will compare here oxygen and nitrogen, which is the less electronegative. Nitrogen is less electronegative than oxygen. That means we know according to this is the rule that means nitrogen should be in center as it is the less electronegative, and here the oxygen that is outside of the nitrogen. So nitrogen, this side oxygen, this side oxygen, and nitrogen is the less electronegative than oxygen, so it is at the center. Next step, that means here a pair of electrons in the middle of the atom so that it forms chemical bonding. You know a pair of electrons by only sharing, it forms covalent bond. Now you can see here oxygen, middle nitrogen, and you count here, this is pair of electron, that is one side 2, this side 2, 4, and here 4 to 6 to 8 to 10, 11, here 13, 15 to 17. Now you can show that 17 electrons are satisfied according to total valency electrons. Now again you see here in surrounding 6 electron, here surrounding 8 electron, here surrounding 8 electron, 16 and 1, 17. Anyway you count that you come to 17. But according to rule it says that a pair of electron that is in the between the atoms as it forms chemical bonding. What is that chemical bonding? That is our covalent bond, which is formed by sharing of electron. Now you can see after that what is the step. That means we will see the octet form. Octet form means whether the oxygen surrounding, that is 8, that this oxygen surrounding 8 and middle nitrogen that surrounding 8 or not. You will check one by one. Now see oxygen here 1, 2, 3, 4, 6 to 8. That means oxygen is 8, that is satisfied. And here comes to this oxygen also you can see 2 to 4 to 6 to 8. Okay, this is also satisfied. Then come to nitrogen, which is the middle of the two oxygen, and here it is 2 to 4, 1, 5. That means it is nitrogen 5 electrons, and that is not following any octet rule. It is less 3 electrons than 8. And so again see this oxygen 8 electron, this oxygen 8 electron, middle nitrogen which is having 5 electrons. So it is not satisfied octet rule. Then come to after that it is let's say it is not a it is only represented, that is why it is called skeleton structure, and it is skeleton structure where we indicate that how many electrons were and where it is present as a pair of chemical bond or other electrons. Now if we can, this one we can represent here, and if this pair of electron from the oxygen is transferred to near nitrogen, between nitrogen and oxygen, again see this pair of electron, if it transfer from oxygen to nitrogen, that is in middle of nitrogen and oxygen, then what will the structure? Now since the pair of electron transfer to here, and here there are 2 pair of electron. Now here you can say that is green surrounded, that is called bonding electron. and other electrons which are free, which are not surrounded by blue, and that is non-bonding electron. Now here non-bonding electron 2 that is transferred to between nitrogen and oxygen and forms a chemical bonding, that is what we call bonding electron. Now see this structure after transfer from oxygen to nitrogen, that is between this nitrogen, that oxygen, what happening? What is here? What are the type of bonds formed between nitrogen and oxygen? How many? How many bonds form? See, this is same here. This is one covalent bond, that is chemical bond formed between this oxygen, first oxygen and nitrogen, and here there are two pair of bonds formed. The pair of electrons that sharing, by sharing it forms two bonds, two covalent bonds. This is one sharing a pair of electron, here one pair of electrons sharing, and here two chemical bond between nitrogen and that oxygen, and here one chemical bond that is here between this oxygen and nitrogen. Now you can say how many bonding electrons present surrounded by number 1 oxygen, number 2 oxygen and nitrogen. Now see, check here. This is the first oxygen. When we see this is only bonding electron. How many bonding electrons there? 2. And here 2 plus 2 plus 2, 6 non-bonding electrons. And now here nitrogen having how many bonding electron here? This is one pair, this is one pair, and this is also one pair. That means here 6 bonding electron and 1 non-bonding electron. 6 bonding electrons of nitrogen and 1 bonding electron. Similarly, that second oxygen, 2 pair non-bonding electron, that means 4 non-bonding electron, and here it is 2 pair bonding electron, that means 4 bonding electron for this oxygen. And after that we will check again any other possible Lewis structure form. This is the Lewis structure 1 for nitrogen dioxide. We will check other Lewis structure, is it possible? Okay, we will see. Again see here, oxygen satisfied by 8 and this oxygen satisfied by 8, but nitrogen that is 5. Similarly, when you come to proper structure of the Lewis structure 1, here only nitrogen having 7 electrons and oxygen having 8, and that oxygen also having 8. Now nitrogen 7 means 1 less than 8, and here it is 3 less than 8, but in Lewis structure it is 1 less than 8. We will see now next second Lewis structure for nitrogen dioxide. Now Lewis dot structure for nitrogen dioxide, that is, it is number 1 structure. Now it is not satisfied because nitrogen having 1, 2, 3, 4, 5 electrons, whereas oxygen having 8 electrons, and also this oxygen also 8 electrons. So that is why if it is not satisfied by 8 and it is only 5 electrons, less than 3 less than 8, that is why this pair of electron from bonding electron can be transferred to the oxygen and this side as non-bonding electrons. Similarly, this pair as non-bonding electrons for the oxygen transferred to the this middle nitrogen and oxygen and form one bonding pair electron. Now, if it is happening, then what is the second Lewis dot structure? The second Lewis dot structure, this one, where this is the two pair bonding electron between this oxygen and nitrogen, and one bonding pair electron between nitrogen and oxygen. And others are non-bonding electron. These two pair are non-bonding electron for oxygen 1. And nitrogen, it is 1 non-bonding electron, and for this oxygen 2 there are 6 non-bonding electron. Now there are two structures are possible, 1 and 2, and that is why you will see what is the formal charge and what is the best one, and all things can be cleared by the formal charge. Formal charge equal to valency electrons minus non-bonding electron minus bonding electrons by 2. Again, formal charge means valence electron minus non-bonding electrons minus bonding electrons by 2. Let us say structure 1 where we can find there is a bonding electron 2. For suppose you want to calculate oxygen 1. This is oxygen 1, this is oxygen 2. For oxygen 1, 6, that is valence electron, minus 6 here, 2, 2, 4, 2, 6, non-bonding electron 6, minus only one bonding pair electron, that is 2, 2 by 2, the result is minus 1, 6 minus 2 by 2, that is minus 1. So I put here minus 1 with red color, that is formal charge for this oxygen, that is minus 1. And similarly oxygen 2, where you can see there are two pair non-bonding electron and two pair that is bonding electron. That is why according to formula valence electron 6, non-bonding electron 4, bonding electron 4. So 6 minus 4 by 2, that is 0. That means for this oxygen the formal charge 0. Here I put in red color, red sign, that is 0. That is the formal charge of the oxygen 2. Then come to formal charge of nitrogen, only one nitrogen where bonding electrons are 1, 2, 3 pair. 3 pair means 6 electron, whereas non-bonding electron only 1. So put the formula 5 with the valence electron, minus 1 that is non-bonding electron, minus 6 by 2 that is bonding electron by 2. The result is plus 1. So see here, what are the formal charge? For oxygen 1, minus 1, oxygen 2, 0, and nitrogen plus 1, that is for structure 1. Then other possible structure, what is the Lewis structure? This one. So again I put here structure 2. In structure 2, we can find here the green color, that is bonding electron, there is no color, that is non-bonding electron. So what happened here, and this is minus 1, plus 1, 0, then how? Oxygen 1, formal charge oxygen 1, how many non-bonding electron? 2 plus 2, 4. How many bonding electron? 2 plus 2, 4. So what is the formula? 6 minus 4 minus 4 by 2, that is equal to 0. This is for oxygen 1. And for oxygen 2, again see how many bonding electron? Only 2, and how many non-bonding electron? 6. That is why here you put 6 minus 6, 6 is the valence electron. Structure 2, see structure 2, here the first oxygen having 4 bonding electron and 4 non-bonding electron, and for nitrogen 1 non-bonding electron and 3 pair bonding electron, in total 6 electron, that is as bonding electron. And for this oxygen 2, only 2 bonding electron, whereas 6 non-bonding electron. Let us calculate formal charge of oxygen 1. 6 valence electron, 4 non-bonding electron, minus 4 by 2, 4 means that is bonding electrons. The value comes to 0. Similarly, oxygen 2, what is the formal charge of oxygen 2? 6 valence electron, minus 6 non-bonding electron, minus 2, this is 2 means bonding electron, and minus 2 by 2, what is the result? Minus 1. 6 minus 2 by 2, that is minus 1. Similarly, formal charge of nitrogen, here valence electron 5 and non-bonding electron, that is 0. Non-bonding electron, that is 1, and bonding electron, that is 6 by 2. That means here 5 minus 1, 4, minus 6 by 2, 3. So 4 minus 3, that is plus 1. Again see nitrogen, here valence electron 5, non-bonding electron 1, and that means 3 pair of bonding electron, that is 6 by 2, that is equal to plus 1. Now here structure 1 and structure 2 just like similar, but oxygen 2 changes to oxygen 1, oxygen 1 changes to oxygen 2, and that is why you can see first one minus 1, here first one 0, and nitrogen remain as it is, here plus 1, here plus 1, oxygen 2 here 0, and here it is minus 1. And so here 2 Lewis dot structures of nitrogen dioxide possible here. This is the one where bonding electron here 2 and here 4, and just opposite this structure 2 where first one 2 pair of bonding electron and next one 1 pair bonding electron. That means again see for this oxygen and nitrogen here bonding electron only 2, and this nitrogen oxygen number 2, that is 2 pair of bonding electron. In structure 2 just opposite, and here it is between oxygen and nitrogen 2 pair of bonding electron, and now the nitrogen oxygen 2 between 2 that is only one pair bonding electrons. Now we will see a resonance structure of nitrogen dioxide. We know the Lewis structure, and here you can say both are same, so both are the best structure. Now we will find what is the resonance structure of this and what is resonance high structure of nitrogen dioxide. Now we will see resonance structure of nitrogen dioxide. We know there are two Lewis structures which are possible. Now they are good, they are stable, and we will find here what is the resonance structure. Now two Lewis structure, they indicate that they are resonance structure. And here this is structure 1, this is structure 2. Now if I will write like this, the green color surrounding that is bonding electron, and here we can represent this one like this resonance structure, or we can write the chemical bonding represented by single and double line. That means here one single bond, here two single bond, here also two single bond, and here one single bond. Single bond means that is covalent bond, and that is here one covalent bond, two covalent bond, and two covalent bond, and here one covalent bond. If one covalent, that is sigma bond, if two covalent, one sigma, one pi bond. Now these are the resonance structure, that is one you can represent by electrons only, and here you can represent by bonds. And now what is resonance hybrid then? Resonance hybrid, then when you mix these two structures, then it is happening, and here the dot like structure, and one is single bond, one is pi bond, that is localized. That is why you can write like dot structure where angle is 134.3 degree, and the length is 119.7 picometer. Now this is very important. Sometimes the question may ask what is the angle between this oxygen in nitrogen dioxide. Then here you can say that is 134.3, and now here the length is also very important, 119.7 picometer. Now this is the resonance hybrid of nitrogen dioxide. These are the resonance structure of nitrogen dioxide. Here you can represent it by electrons, bonding and non-bonding electron. Here represented by bonds and non-bonding electrons. Then what is NO2 minus? Sometimes students may confuse NO2 minus, that is not any molecule. This is one ion. What is the ion? Nitrite ion. So remember, if the question asks NO2 minus 1, don't do the Lewis structure of NO2, because NO2 is different from NO2 minus 1. So NO2 minus 1, that nitrite ion, and here different from nitrogen dioxide, which is a molecule. Nitrogen dioxide is a molecule, whereas NO2 minus 1, that is called nitrate ion. This is one ion, polyatomic ion. And nitrogen dioxide generally brown colored gas. What is nitrogen dioxide? It is a molecule and is brown colored gas. I hope it is clear. NO2 minus 1 polyatomic ion, and here don't do the Lewis structure NO2 minus 1 as NO2. NO2 is totally different to NO2 minus 1. Later in class I will explain what is the Lewis structure and resonance structure of NO2 minus 1. I hope it is clear to you what is the Lewis structure of nitrogen dioxide, resonance structure and resonance hybrid structure of nitrogen dioxide. And thanks for watching my video, and I hope you will subscribe my channel B.L.D, Short and Sweet in Chemistry. Thanks again to all.